Welcome to the first video on complex truth relations. If you have not watched the video on basic truth relations, do that first. Complex truth relations are truth relations composed of two basic truth relations. This video covers equivalent, which is the combination of sufficiency and necessity, and contradictory, which is the combination of contrary and subcontrary. Equivalent propositions are propositions that are sufficient and necessary for each other. Recall that one proposition is sufficient for another just in case the truth of the first means that the second is also true. Thus, true makes true. So, if two propositions are sufficient for each other, if one is true, so is the other. Recall that one proposition is necessary for another just in case the error of the first means that the second is also false. Thus, false makes false. So, if two propositions are necessary for each other, if one is false, so is the other. What this means is that if two propositions are sufficient and necessary for each other, they have matching truth values. Consider my hand in poker right now. I have a royal flush. The proposition, I have a royal flush, is equivalent to the proposition, I have an ace-high straight flush. If one of the propositions is true, so is the other. If one is false, so is the other. Here are some examples of equivalent propositions. Quite often, philosophers and others try to provide definitions by providing equivalent propositions. Consider the first pair of propositions. A square just is an equiangular, which means equal-angled, equilateral, which means equal-sided, quadrilateral, which means four-sided figure. Thus, the proposition, this figure is a square, is equivalent to the proposition, this figure is an equiangular, equilateral, quadrilateral. The same is true for the other two examples. That a number is even just means that the number is an integer which could be equally divided by 2. And so on for the third example. For a memory mansion image, it's easy for me to use the equals sign. You might want to use something else. To reinforce the nature of the relationship, that is matching, we have 2 cups of tea for true makes true and 2 falling guys for false makes false. Since equivalence is the combination of sufficiency and necessity, we put equivalent on the left-hand side. Furthermore, we add our 2 cups of tea and our 2 falling guys. Equivalence is a combination of sufficiency and necessity. Equivalent propositions have matching truth values. Contradictory propositions are propositions that are contrary and subcontrary. That means that at most one can be true and at most one can be false. Thus, they have opposite truth values. For an example, suppose I'm picking playing cards and I pick a red card. Since I pick a red card is true, the proposition I pick a black card is false. These two propositions are contradictory when we're talking about a standard deck of playing cards. As with equivalent propositions, if one proposition is contradictory to another, then the second is also contradictory to the first. Here are some other examples of contradictory propositions. If you're dealing with numbers, the number is either even or odd, but not both. The same is true when dealing with animals. Animals either regulate their body heat or they don't. During the day, it is either AM, that is antemeridium, or PM, that is postmeridium, but not both. For a memory mentioned image of contradictory, I think of a cobra with a dictionary. Cobra dictionary for contradictory. To reinforce the nature of the relationship, we have our teacup followed by our falling guy. Tea makes false for true makes false. Then we have our falling guy followed by a teacup. False makes tea for false makes true. Since contradictory is a combination of contrary and subcontrary, we place contradictory in the far right-hand side. We also have our combination of falling guys and teacups for the relationship. That's it for equivalent and contradictory. We still have 2 more relations to go. They are considerably more complicated. As a preview, you might look at our box here and try to figure them out.